So today I'll talk a little bit about emotions and how they play into psychology and kind of what that looks like. So emotions are kind of defined as being experiential and subjective responses to various stimuli, both internal and external. So everyone experiences emotions differently, and they respond in different capacities and in different ways to those stimuli. And emotions and the responses that we call emotions have both physical and behavioral components. So it's not just a simple singular process, but it's actually kind of multiple processes that meld together to create what we then call emotional. And so there are three components to emotions as we talk about it in psychology. First is physiological, so your body. Next is behavioral, the actions. And then the third component is the cognitive portion, the mind, what your mind does and how your mind reacts. So we're going to look at some of the theories behind emotion, and the first is the Jameslange Theory. And this was kind of one of the first theories that came about. It has since been discredited for reasons that will seem obvious to you in a second, but the basic idea behind this is that environmental stimuli cause physiological changes and responses. And then the Jameslange Theory argues that the experience of emotion is the result of a physiological change. So if an argument, the example is, if an argument makes you angry, then it's the physiological responses like heart rate growing up, increased respiratory rate, that prompts your experience of anger. So the argument doesn't make you angry. What makes you angry is your heart rate going up and your respiratory rate going up. We know this is incorrect because we have sometimes the same physiological responses that lead to various emotions, right? Like we cry because we're sad or because we're happy. And sometimes when you cut onions, you cry, but crying alone does not make you sad. So the physiological response alone does not make you sad. There has to be something else. So that's where the Jameslange Theory kind of falls short. But the essential elements to it is that there's some sort of stimulus that creates a physiological response, and that leads to some experience of emotion, as we call it. Then there's the Canon theory, and it's a response to the Jameslange Theory in many ways. And it argues that the physiological response to emotion and the experience of the emotion happen nearly simultaneous. And that's a result of whatever stimulus causes the emotion. So the idea, if you dive into it, like what's actually happening in the body, according to the Canon theory, is that the emotion-provoking stimulus, again, whether that's internal or external, doesn't really matter, stimulates the thalamus. And as it stimulates the thalamus simultaneously sends a message to the autonomic nervous system and to the cerebral cortex. And at that moment, the messages to the autonomic nervous system produce the physiological arousal, and the messages to the cortex produce the experience of emotion. But those happen at the same time. So the stimulus occurs, it happens and is sent to the thalamus, and the thalamus sends the information to the autonomic nervous system and to the cortex at the same time, thus having a response simultaneously. And then the other theory that is probably the most accurate, the one that we kind of consider the best now, is called the TwoFactor Theory, which was proposed by Schachter and Singer. And it adds a cognitive element to the previous theory, the Jameslange and the Canon theory. And the two factors that contribute to the TwoFactor Theory are physiological arousal and how we cognitively label the experience of arousal. So how we, in our mind, interpret that. And so we know this because, again, if we look at the Jameslange Theory, as we had talked about why it's discredited, is that many emotional responses have similar physiological properties, but the emotion that we experience is the result of the label we apply. So crying happens for a lot of emotional responses. And if we're crying at a wedding, it's because of happiness. And we know this because in our mind, we're aware that we're at a wedding and thus we're happy. But if we cry at a funeral, we are sad because we are cognitively aware that there is sadness. So again, the stimulus happens and there's some physiological response. At the same time, there's a cognitive appraisal of the situation. Where am I? What's happening? What's going on? And these two together then lead us to experience the emotion. So I am crying because I'm at a wedding. Therefore, I am happy. I am crying because I'm at a funeral. Therefore, I'm sad. And so it adds that other element of cognitive appraisal of our ability to understand and think about our reactions that previous theories didn't have. When we talk about emotions, what we find interesting is that they're very much universal. And so Charles Darwin assumed that emotions had strong biological basis. And if he was correct, and we now think he is, it means that emotions should be experienced in similar, if not identical ways across all cultures. And they should not only be experienced, but they should be expressed the same ways. And this is true. And one of the ways we know this is true is through the work of a guy named Paul Ekman, who observed facial expressions amongst various cultures. And he pointed out that the expression of emotions were almost identical in all of these cultures based off the emotion that they were feeling. And so Ekman worked even deeper than that and identified 6 basic emotions: anger, fear, disgust, surprise, happiness, and sadness. And so he says that the facial reactions to anger are almost identical across all cultures, and they are different from fear, which are also identical across all cultures. So pretty interesting that the idea of emotions is a really universal human concept. And so to understand this, there's some idea that emotions are thought to be related, evolutionarily speaking, to the adaptive role of emotions. And emotions can enhance survival by being a useful guide for quick decisions. So if you are scared, if you feel the emotion of fear, that is a good indication that you should get out. Or if you feel the emotion of anger, it's a good indication that you should get ready to defend yourself, right? It's these emotional kind of initial actions that help us to make quick decisions and react. And this could have been useful in saving our lives. In social contexts, emotions are a good way for nonverbal communication and to express empathy. And this is why it's really important to have meaningful conversations face to face, because if you are getting emotional, that nonverbal element is almost as important as the verbal element or the typed element or whatever it may be. So that's the universality of emotions. Getting a little more into the details, there is the limbic system plays a key role in emotion. And again, the limbic system is the brain structure on both sides of the thalamus, and that's basically, we view it as the emotional center of the brain. And the main structure that's involved in this emotion is the amygdala, and it communicates with various parts of the brain. It communicates with the hypothalamus, and that controls the physiological aspects of emotion. That then relays information out to the nervous system about what to do. It also communicates with the prefrontal cortex, which controls approach and avoidance behavior and works on calming us down and those sorts of things. The amygdala also plays a key role in expression of fear and anger. So that's the role that the limbic system, particularly the amygdala, plays in emotions. And emotions are very much deeply rooted in our brains, in memory, in decision-making, and then even in the nervous system. So when we form memories, oftentimes along with the actual memories, we encode the emotions that we felt along with that. And so we know that when we recall an event, oftentimes that recall action brings about the emotions that are associated with that event. And sometimes this isn't even a conscious decision. So if you are driving through an intersection where you had previously gotten into an accident, you may subconsciously tense up and experience fear or anxiety. Not consciously, but because your memory is recalling that event, and encoded with that event is also those emotions of fear. This also is why if we remember sad events, we may start crying, right? Like, it's these sorts of things. It makes it difficult to, it also helps explain when we're dealing psychologically with people who suffer severe trauma, why it's hard to talk about, because talking about that trauma can bring back those emotions. The prefrontal cortex, which I had mentioned earlier, is really, really important for emotional experience. and decision making. And the prefrontal cortex, if you imagine the amygdala's role is to make you angry and kind of excite and arouse everything going on with these emotions, the role of the prefrontal cortex is to come in and be like, let's everybody just calm down. We all just need to calm down right now. And that helps us make more calm and rational decisions. It's a way to prevent us from overreacting to our emotions. It's a way for us to reduce them back closer to our baseline to make cognitively smart decisions. And so that prefrontal cortex is super, super important for emotions. And it takes a long time to develop, and it's not completely developed until people hit their mid-20s, which explains teenagers, essentially. It explains rash decision-making by teens and early 20s. It explains a lot of things. And any damage to the prefrontal cortex also leads to people who struggle with emotional control and emotional stability. And so that's a really, really important element of the brain when we talk about emotions. Then looking at the nervous system, the role the nervous system plays, the autonomic nervous system is responsible for controlling most of the organs and glands. And so when we experience an emotion, we have this kind of activation of the autonomic nervous system that controls arousal, and it sends information to one of two places. Either the sympathetic nervous system, which provides our fight or flight response. Say if you're afraid or if you're angry, it releases those hormones and those chemicals and fires those muscles that are needed in order for the fight or flight to take hold. And then it could also control or send information to the parasympathetic nervous system, which provides signals for us during our calm resting state and can get us back towards our calm and our rest. And so the nervous system does play a role in emotions in terms of increasing the heart rate, respiration rate, whatever it may be that goes along with those emotions. And then the last thing we'll talk about when we talk about emotions is stress. And stress is something that causes a person to feel challenged or endangered. And most stressors are everyday events, like traffic or some holiday or schoolwork or going to school or seeing people. But it could be significant life-changing events like death in the family or some major traumatic accident or something like that. So stressors come in many, many forms. Some are transient, which means they're just temporary challenge. And some are chronic, and these chronic stressors can have a negative impact on your health. And so this is why it's really important to not put yourself in stressful situations and to try to avoid them, because there are serious long-term physiological problems associated with really high stress levels. The response to stress, our body's response to stress, is very much related to the fight or flight mentality. And it was developed by Walter Canon, and we call it the general adaptation syndrome. And the idea is that there are basically 3 stages of response to prolonged stress, and those are alarm, resistance, and exhaustion. So the first is alarm, and that is the arousal of the sympathetic nervous system. Your body is energized for immediate action when you are under stress. It is the activation of that fight or flight network. After a while, you have what's known as resistance, and resistance is the result of your body trying to rebound and go back to its baseline, to remove itself from the fight or flight mode and to go back to its normal daily function. Because the body cannot be energized forever, right? Your body's just not built that way. However, if the stress persists, if that stressor persists, the body is not able to go back to that baseline system. And this could then lead you to the third stage, which is exhaustion. So again, you have alarm, which is immediate fight or flight, and then resistance is your body trying to go back to normal but unable to because that stress still exists. And so you end up at exhaustion, and it's where your body's resources are exhausted and the tissue cannot be repaired. And so your body basically just starts shutting down. And in this mode, your immune system becomes impaired in its functioning. So if you are stressed out, it is more likely you will get sick. So if you find people in high-stress jobs or in high-stress situations, they often end up sick because of that. So it is important that we find ways to control our stress. And psychologically, the effects of stress are not just psychological, but they're also physical, and it leads to sickness and other problems. In terms of how people respond to stress, we kind of can basically subdivide them into two groups. Type A, which when they are faced with stress, they have competitiveness, a sense of urgency, and elevated feelings of anger and hostility, and they're ready to go. This is the type A personality. And then we have type B, which are typified by low levels of competitiveness, low preoccupation of time, and they're generally more easygoing and just kind of go with the flow. And so that's, generally speaking, how people react to stress. There are obviously major subcomponents within each of those types, but those are the two major divisions that you could argue exist for people dealing with stress.